Moon nukes, what's up with that? The space race is going nuclear, but we are in the race. We're in a race to the moon. NASA Administrator Sean Duffy expected to announce plans this week to build a nuclear reactor on the moon. To have a base on the moon, we need energy. Here to discuss all of this is astrophysicist Neil deGrasse Tyson.
Well, as you may have heard, the United States, NASA, has an accelerated plan to deliver a nuclear power plant to the moon. Plant actually overstates it. It's a nuclear power device that can produce 100 kilowatts of power. So, how much energy is that? Well, you know how much energy a hairdryer draws? Typical hairdryer might draw 1,000 watts. If you delivered hairdryers to the moon, how many hairdryers could it sustain? 100 of them. 100,000 watts. 'Cause each hairdryer is 1,000 watts. So, obviously that's not what NASA is planning. I just want to give you a sense of how much power that represents. It's not a major power plant. It is an energy source that would be sufficient to sustain a small colony, a small settlement. So NASA has pushed forward the timetable over which that would be delivered. It was going to happen anyway. They just moved it forward. And that would make great clickbait all around the internet. Trump administration is going to put nukes on the moon. The real story is NASA and the Artemis program that was going to put a power-generating system on the moon, farther away in the future, has moved it up on the calendar. That's really all that happened there. The urge to attach it to the Trump administration is strong. But here's what's interesting about NASA. Realize NASA is 10 centers across the United States. 10 centers located in 8 states. And variously, those 8 states will vote 4 red, 4 blue, 3 red, 5 blue, 3 blue, 5 red. And so that's interesting, which means NASA is embedded into the political spectrum of America. What that means is the vision statements of NASA as an expression of what the country wants to do actually transcends presidents, and on some level, therefore, transcends politics. So it's how and why Kennedy can say, let's go to the moon, and Nixon picks it up. And we keep going to the moon until we look over our shoulders and Russia isn't there. Oh, that's why we went to the moon, because Russia was going to make major leaps and bounds in space, and we had to show them that we were better than the godless communists around the world. These are the driving forces. So what happens in the 201S 2014-15-16? China says, we want to put taionauts, their word for astronaut, on the moon. China is like our frenemy, right? We're looking over our shoulder because, what are they about to be the new world superpower, economically, socially, culturally? What's going on? So Congress is a little spooked by this, and we say we're going to go back to the moon. Thus was born the Artemis program for the United States to go back to the moon. Recognize that between 1972 and then going back to the moon was not a sufficient enough goal to do on its own without some kind of forcing agent behind it. Just the kind of forcing agent that sent us to the moon in the first place. Okay, so now we have the Artemis program. It's a spaceship. The first Artemis went to the moon, went around the moon, came back, landed, but it had no astronauts. That's Artemis 1. Artemis 2 is going to go to the moon, orbit it, and come back. That'll have astronauts, but it wouldn't have landed. Artemis 3 is going to go to the moon and land with astronauts. That's the plan, and it'll keep going. So, Artemis 4, 5, and it's going to, and in the plan, you can look it up. In the plan, there's a building of a base there, a sustainable presence. The moon will become a new second home for us. So, you need energy sources. While you're there, you're going to be doing experiments. You want to live. You want to stay warm. At night, it gets very cold on the moon. In the daytime, it gets very hot on the moon. It swings from 200 degrees below 0 Fahrenheit to 200 degrees above 0. There's no atmosphere to smooth out that temperature difference. So, how long is a day on the moon? A day on the moon lasts a month. Where do you think the word month came from? It's approximately the cycle of phases of the moon. And the cycle of phases of the moon is the moon going through one moon day. If it takes a month, that means the moon has 2 weeks of sunlight, 2 weeks of darkness. So you can set up solar panels. That's another way you can get energy on the moon. Solar panels, they are cheaper and lighter than a nuclear plant, but there are other issues with it. So for example, you can set them up, and for 2 weeks you get nothing but sunshine. And even when the sun gets low in the horizon, there's no atmosphere. So the sun near the horizon is just as bright as the sun overhead. And so you get the sunlight no matter what, 24/7 or however you might measure that on the moon. Then the sun sets. If you made more energy than you needed, you can put it into storage batteries and then use those when nighttime comes. However, you ever try to use a battery at 200 degrees below zero? We're not there yet. Batteries don't like being cold. So, there's a problem of how you would generate or draw energy from whatever are your devices when it's nighttime on the moon. These issues are resolved with a nuclear device. And what is it? It's a fission reactor. It uses uranium. There's still people who are a little spooked when they hear the word nuclear. And I don't know if you know this, but everyone in France knows this. 2/3 of their power is generated by nuclear power plants. And it's been that for 40 years. 2/3. They make so much energy that they export their excess to the tune of more than 3 billion euros a year, and they're just fine. You ever hear Frenchmen say, "Oh, I'm afraid of nukes"? No, they got it figured out. So it has to do with design. Is the design modern and sensible and resistant and the like? Oh, you might have to worry if you had a nuclear device there. You see what the surface of the moon looks like, right? It's got craters. That means the moon has been hit. Now, it doesn't have an atmosphere to protect it from the smaller objects, but a bigger object, even on Earth, is coming through. Suppose an asteroid hits the nuclear device. I'd kind of be more worried if an asteroid hit me. That's just between you and me. But there are easy engineering solutions to this. You can just bury it. You can bury it. It's a self-contained device developed. There's prototypes being used in the military right now at military bases. They're good for remote locations. The future of this could be quite bright. So, if we do this before 2030, we will beat China and Russia to the moon with this technology. And apparently that gives Congress some bragging rights. All right. And okay, that's what it takes to become a multi-planet species. Okay. But I'm not so naive as to suggest that when we first went to the moon, it was just for the glory of exploration. No, it wasn't. The statements you might read that we want to set up base camp on the moon so that it's a station to continue on to Mars. That's less realistic. It doesn't really make sense to fly to the moon and then continue on to Mars because it takes fuel to land on the moon. On the moon, you need fuel to slow down. So if you're going to go to Mars, who needs the middleman? Just go straight to Mars. So there are even books on this one by Robert Zubrin called Mars Direct. Point is, if you really want to go to Mars and that's your target, you don't need the moon for that. You just go straight to Mars. Now, what's good about setting up a base camp is when you send astronauts, they don't have to carry all the food that they need going forward. You know why? Because we could just send spaceships that have no crew in them, and they can land there and all the food is there. We can do that. So the supply routes, the supply chain does not have to be conjoined with the delivery of the astronauts themselves. In fact, we can send all the camping equipment they need up front, and when they step off their spaceship, they just put it all together, and there it is. So that could be fun. Oh, and one final point. All of this is targeting the South Pole of the moon. By the way, none of the Apollo astronauts landed anywhere near the South Pole. They landed in the large flat areas, which are called seas. They're called seas because early people saw that they were flat and smooth and they thought maybe the moon had oceans. Apollo 11 landed in the Sea of Tranquility. Many of the seas are named after psychological states. The South Pole? The sun never gets very high in the sky, and you have craters with crater rims where the sun never gets high enough for sunlight to reach the bottom of the crater, so that there are places on the moon in the middles of these craters that literally the sun don't shine. So if the sun don't shine at the bottoms of these craters, anytime the moon had been previously hit by a comet, which have high water content, the water molecules sort of drop onto the surface. If the sun hits it, they'll evaporate and escape into space. If they fell into the middle of a crater near the poles, it's a cold trap. And in a cold trap, it is hundreds of degrees below zero, and it never gets warmer than that. The water molecules are there to stay forever for billions of years. So we have billions of years accumulation of water at the basin of polar craters. Water is pretty good. You might want to drink it while you're there. Okay, now it's not just, it's not a bottle in a refrigerator waiting for you to take. You actually have to mine the water molecules out of the surface of the moon to obtain this. So you need a mechanism to do that. But we have very good evidence that there is indeed water there, fulfilling the expectations for it being a cold trap and the moon getting hit by comets over its multi-billion-year lifespan. All right. So you have the water to drink. Water is H2O. If you have another machine that can split the water molecule into hydrogen and oxygen, that's rocket fuel. It's one variety of rocket fuel. If you have an A hydrogen tank and an oxygen tank and then you merge them, the hydrogen joins with the oxygen to make the water molecule and is highly exothermic. Energy is released. So you can go to the moon, we sent the supplies up front, take the water out of the crater basins, drink some of it, make rocket fuel out of the rest, and now you have rocket fuel to come back to the Earth. In NASA, they call this ISRU, in situ resource utilization. There are no permanent settlements anywhere in the solar system unless you have some kind of ISRU. Later on, you bring up a digital printer. You just dump some lunar regolith into it, like lunar soils, and maybe it'll melt it and fuse it and turn it into pottery or whatever you need. Perhaps a future 3D printer will get that for you on the moon. I'm loving it. That's Moon Nukes on Star Talk. Neil deGrasse Tyson. As always, keep looking up.
We've spoken a lot about the impact politics is having on science. So when the US attempts to fast-track the next generation of space nuclear technology, at the risk of billions in taxpayers' dollars and safety of our astronauts, perhaps the question isn't can we do it, but why are we doing it? While NASA sees this as a necessary step, critics warn the timeline may be dangerously rushed and politically motivated. That gap in knowledge is how political agendas steer the course of science without most people realizing it, shaping what gets funded, cut, and why, until we're not sure if we're driving toward breakthroughs or dismantling the very science that's fighting climate change, developing new medicine, and protecting humanity here on Earth. That's why we think Ground News is one of the most important platforms available right now. They built the only app and website helping us separate agent-driven narratives from real science. By pulling in the world's media from research to political perspectives, you understand the full scope of every story. Founded by a former NASA engineer, it has the same precision you'd expect for a space mission, but it works like a smarter version of how you're already staying informed. That's why we've partnered with the platform for years now to make sure our viewers can find the facts missing from their news feeds with data we've never seen anywhere else for nearly half the price. Just go to ground.news/startup or scan the QR code to get the same unlimited Vantage plan we've been using for $5 a month. Decisions about our future are being made right now by people who may not understand or care about the long-term consequences of their actions. This app is how you stay ahead.